Okay, this is Mr. Elmhorst with the math lesson. We're going to be looking at writing and solving just basic one-step equations. So the first thing we want to point out, there's a difference between expressions and equations. So expressions do not have an equal sign. So an expression is going to be a mathematical sentence, but it's an incomplete sentence. So in the word form, looking at this first expression here, we have 2 times the variable x plus 3. So in word form, we can just write out 2 times x plus 3. It's a very simple expression. And notice I said 2 times x, because if you have 2 of these variable x's, then if you only had one, you just have an x. But then you times 2, where the number in front, put a little dot in there. So if you have a number right next to a letter, by default, that's going to be one of our multiplication meanings. So equations are going to have the equal sign. So notice the difference. We have an expression that's equal to 3. So there is an equal sign. Okay, now the variable, let's identify this here. We'll get to that. So we have 2 times x plus 3 is equal to 3. So just noticing the difference between expressions and equations, where there's a comparison being made within the equation. Now, some of the equation terminology that we need to get familiar with is right here. If we have numbers that are added or subtracted, these are called constants. So please label that up above with an arrow. And constants in the expression or equations are some things that are added or subtracted. And if you want to put the little symbols there, that's fine too. So constants are added or subtracted. Now this other word, coefficients, they're the other thing, and the coefficient goes directly with the variable. And that is called a coefficient. So the coefficient is either multiplying or dividing. Or dividing the variable. So each equation, the math that's going on is either going to be adding, subtracting, multiplying, or dividing. Now the variables are unknowns, but let's call this they are the input to the equation. It's what you need to put in, and they're represented by letters. And they can be any letter, A, B, C, D, X, Y, Z, M, Z, S, T, whatever letter that represents the situation that you might be trying to solve. So how do we solve for variables? When we need to find the input to a situation and there's a letter, we're going to use inverse operations or reverse. And there's another word that we could put in here is opposite. Let's just put those in parentheses. We have opposite operations, inverse operation, reverse order, normal order of operations. The goal is to identify the variable, or you could even isolate the variable. The goal is to solve for the variable, or we want to isolate the variable, get it by itself on one side of an equation so we can identify. We can identify the variable, isolate and identify. So the normal order of operations, we are going to do parentheses, exponents, multiply, divide, add, or subtract. So when we know all the numbers, we're going to follow the same order of operations. But if a number is missing, we're actually going to do the order of operations backwards. And instead of PEMDAS, how would we possibly say PEMDAS backwards? Subtract or add, divide or multiply. We are going to do, what is it, SADMAP? SADMAP, I don't know if that's an actual thing, but it's something to keep in mind that when we're solving, we're going to subtract or add, and then we're going to multiply or divide to solve. All right, so let's take a look at the first example. The first example should look like a part-part total model from 3rd grade and 4th grade. So we have x and 5 equal to what? X and 5 is the same length as 10, so we could write an equation x plus 5 equals 10. All right. The strategy I'm going to teach is find your variable term, and then circle it. The variable term is the side that you're going to focus on to start to solve. And then what is happening to the variable? Is something being added or subtracted to it? Something is being added. So the opposite of adding is subtracting. And when we do an operation to one side, we're going to do it to the other. So if we subtract 5 on the side with a variable, draw a line down through the equal sign, and whatever we do to one side, we are going to do to the other side of this comparison or equation. Now bring the variable term down to the next step, and then we do what it says, which is 10 minus 5. And this is a simple one check, one step equation. And that makes sense. So what is the input to this situation that would make it true? What do you add to 5 to give you 10? 5. So 5 plus 5 equals 10. So the variable that makes it true, x equals 5, would check out. So example, we have a comparison being made. In the model, we have part equal to 60. So how many parts are here? 6. So we have 6c, or we could do 6.c, and it's the same length as 60. Okay. So if we knew what the input number was, something times 60 equals, or something times 6 equals 60. If you don't know what that something is, then we need to do inverses. What's the opposite of multiplying by 6? So I'm putting in a line down through the equal sign on purpose. So if we divide by 6 on the left side, we go to the other side and divide by 6. And we can represent division with a fraction. 6 divided by 6 is 1. So we have 1c, and that is equal to 10.